Hello everyone. Today we are in the chapter 5 and our discussion topics is processor status and the flag registers. The first topic is flag register. In 8086 processor we have 9 individual bits which are called flags. In the status flag reflects the results of computation. By index we can see here are several flags. The status flag. The status flag is located on index 0, 2, 4, 6, 7 and 11. And another section of flag is the control flag. Those are located into 8, 9 and 10. Carry flag. Here the status flag is defined as 7 number position, which is SF. Now the carry flag, which is CF, the index number 1. Here if no carry, then it will denote as 0, and if there occurs a carry, it will set to 1. Now the parity flag, PF. PF is in the index number 2, which is for the parity. If there are odd parity, then it will set as 0, and if there are even parity, then it will set as 1. This flag is set to 1 if the lower byte, the result, contains the even number of ones. That means the lower section are from 8 to 0. In this section, if the number of 1 is even, then the parity is 1, and if they are odd, then the parity is 0. Now the auxiliary. Auxiliary carry defined as AF. Auxiliary carry will be 1 if there is a carry out from bit 3 on addition. That does mean we are now in the index number 3. If we have, after addition, suppose we are adding 4 bit numbers and the result is 5 bit. That is why from 0 to 3 index the result becomes 0 to 4. Then the auxiliary carry occurs, and that's why it is on the index number 4 position, which is AF auxiliary flag. Now the 0 flag. 0 flag is set to 1 if the result is 0, and if the result is not 0, then the ZF 0 flag will set it to 1. If you are subtracting 1 from 1, then the result is 0. That time the 0 flag is 1. Otherwise it will 0. Now the sign flag. Sign flag defined as SF, which is situated in SF in the 7 number state in index. SF equals to 1 if the MSB, that means most significant bit of the result, is 1. If we are going to a signed interpreter, is SF equals to 0 if the MSB equals to 0. That means if the most significant bit in this section, which can be anywhere, the most significant bit in the index value, if the most significant bit is 1, then the sign flag is 1. That does mean you have the output which is 1100. The first value is 1 here, so the most significant bit is 1. So here the sign flag is 1. If it is 0, as example, the output is 0, 1, 1. That's in this example the most significant bit MSB is 0. That is why the sign flag will be set to 0 here. Now trap flag. If this flag is set, the processor enters into a single step execution mode. Interruption flag. If this flag is set, then mistakable interruption recognized by the CPU, and the direction flag. This direction flag is set to 0 if the string is processed being from the lowest address to the highest address, and the string to be processed from highest address to the lowest address. Then it will increase and set the direction flag to 1. You can easily understand by going through these two lines. Now, the overflow flag. Overflow flag will be 1 if a signed overflow occurs, otherwise it will be the 0 one. So those are the combination of flags in 8086. The condition of flags is very important for 8086. This question is very much important for your examination. So read flags very carefully. Flag name and symbols. Here are the name of some flags and their symbols are given. Here are the status flags and here are the control flags. How instruction affairs with the flags. The affairs on affection of flags with the instruction is given in this diagram. Move and exchange don't have an effect on flags. Addition and subtraction have effect on all type of flags. Increment and decrement effects on only CF section, and NEG in all section, but if CF equals to 1 unless the result is 0. In this section we can see that we are adding FFF to the FFFF. If we add them, we get the result as 1 FFF then E. Here by this condition we can say that SF, which is a sign flag, is 1 because of here the most significant bit is 1 here. That's why 1 becomes the MSB and SF, which is a sign flag, becomes 1. Now the parity one. Parity flag equals to 0 here because the number of 1 is odd here. So the PF equals to 0. And now ZF, the 0 flag, is the result is 0? No. So the 0 flag will set to 0. If the whole result is 0, then the 0 flag could be 1. Now the CF, the carry flag. Yes, we have a carry because we are adding 4-bit numbers, but the result is 5-bit. That is why we are having a carry, and the CF flag is 1. Now the OF. OF is equal to 0 because the sign of the stored result is the same that the number being added, and the binary addition is carried into the MSB and also carried out. That does mean OF flag is overflow flag. The overflow flag is 0 here because this one is sign. This one is denoting the sign flag, so it is not overflowed. So here the overflow flag is 0. Here is another condition for your practice. You can practice this one at your home. Have a snap of this one. This is another example for your practice. This one is another one. Never fear because the description of those flags are given below. So first you should try by your own If you fall, then you should follow those instructions. That's for today. Thank you.